Hey Math 1, we've got our third video of Chapter 4, graphing linear models. So basically what you guys are going to be doing is graphing lines. Now they're all going to have an application word problem context, so it's not going to be as simple as plot some points that are given to you. You have to figure out what the starting points are and the rate of change from the problem. I think you'll find it's not too bad. The difficult part is going to be, how do I manage limited space and graph it properly that way? That's what I'm here to teach you today. All right, so we're cooking hamburgers on the grill. The overall weight of a hamburger decreases 2 ounces every 9 minutes if it's cooked at a certain temperature. Now, if we toss a 15-ounce burger on the grill, I'm asking you guys to graph the weight of the burger as it cooks, and then we're going to write an equation of that line, okay? So I'm going to, first of all, just map out off to the side the two really important pieces of info that we've got here. Where do we start? And what's our rate of change? Those are the two most important pieces of this graph, and if you can determine those, then you'll be in good shape. So the starting point. We're talking about graphing the weight of a hamburger. So, what is its weight at the start? Well, when we throw it on the grill, it's 15 ounces. So we're going to start at 15. And the starting point is always a placement on the y-axis here. Okay, so keep that in mind. The rate of change looks like it's the rate at which the weight decreases. It decreases 2 ounces every 9 minutes. So you're going to go negative, because it's decreasing, 2 ounces per 9 minutes. Remember, ounces goes on top, minutes goes on the bottom. The top of the rate of change will always match the unit of the starting point. The top, you might want to just write that down on your notes. The top of the rate of change, the numerator, ounces, should match the starting point. If you got that down, you're going to be golden. So, with that information, let's graph. So we kind of have a limited space here. I purposefully gave you guys a limited space so you have to make some interesting decisions here. The x-axis, the y-axis. X-axis is always time if time's involved. So this would be that the minutes that the burgers are cooking on the grill. This right here is going to be the weight of the burgers in ounces. Weight of hamburgers, or it's just one hamburger. And then the unit for that's going to be ounces, or abbreviated OZ. So, we should probably state off to the side that X represents time in minutes, and Y represents weight in ounces. So, start 15 ounces on the y-axis. So there's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots, and we know it's going down. So this is going to be its peak. It's not going to go up from here, it's going down from here. So what I'm going to do is count by twos. So 2 ounces, 4 ounces, 6 ounces, 8 ounces, 10 ounces. If we count by twos on the y-axis, we certainly will make it up to 15. There's our starting point. Our starting point is 15 ounces directly on the y-axis. Now, on the x-axis, I'm limited to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, about 16 spots. So I think on the x-axis, I'm also going to go by twos. 12, 14, 16, 18, 20, and so on and so forth. Okay, so our rate of change tells us how far to rise over how far to run. So starting at 15, it's a negative 2 ounce rise. So negative 1, 2 would be the down. Then you're going to go right 2, 4, 6, 8, 9. And again, you're going to keep decreasing. Down 1, 2 ounces every 1, 2, 3, 4, 5, 6, 7, 8, 9. And you plot as many of those as you can on your graph. Down 1, 2, right 2, 4, 6, 8, 9. I'm gonna just stop there. Okay. And it's going to be a line, and this line should continue beyond where my ruler stops. But yeah, this is a visual representation of the weight of the burger. So what are the expectations? Just tell me what X and Y are. Tell me what the starting point and the rate of change is, and then make sure your graph makes sense with its units like this. Now, what about the equation of the line? Well, what I'm going to get you guys in the swing of, like get you used to, is it's always going to be y equals, this is like a formula alert, the starting point plus or minus the rate of change times x. So I know I didn't really explain how this is happening, but it seems to me like you're always starting here, and then you subtract if it's going down, you add if it's moving up. You multiply your starting point by x, and you're going to get each point on here. You're going to see how this fleshes out in future lessons. I just want you guys to get a chance to just write the equation. So for this one in particular, it's going to be y equals 15 is my starting point. I'm choosing the minus here. My rate of change is 2/9, and then I'm multiplying that 2/9 times x. And that's going to be the equation of my line. Whew. Okay, so that was a lot. Let's check out another example. Start from fresh and see if we can make sense of it. All right, so for all you baseball fans out there, we've got a guy named John. He's a professional baseball player, not in the major leagues and not really in the minor leagues either. It's just a newly formed B League. I just made that up. He earns a modest monthly salary of $2,200, but he's promised a $100 bonus for every single home run that he hits. Or no, smashes. So graph the amount of money he will make in a month based on the number of home runs he hits. So I think you guys, you understand, like, we're trying to get the starting point first. And yeah, he's starting out at $2,200. It's the rate of change. Well, he's going to get $100 for every one home run he hits. Excuse me. I will use HR for home run. And I'm going to keep it positive because he's earning money, not losing money. Yeah, so now our X represents home runs hit. And our Y is going to represent dollars made. Or we could say money earned. So this one's in dollars. I think we're... Do we have an announcement? Sorry about that. So we've got our x-axis and our y-axis. Yeah, let's get to it. This is really wonky because the $2,200 is kind of a big amount to start with, considering we only have 11 blocks and it's going up, right? You're making money, so the line's going up. So I need to be really careful about the intervals I go by. We know home runs is the x-axis. I think it's pretty safe to just say this is 1, this is 2, this is 3, this is 4, this is 5. It's the y-axis that I'm concerned about. This is the money earned. I could count by hundreds, but I'd run out of room really quick. I'm going to count by 500s, and we'll see what that does. So 500, 1,000, 1,500, 2,000, 2,500, and so on and so forth. It just keeps moving up incrementally by 500s. All right, so our 2,200 is right here. It's not quite halfway between 2,000 and 2,500. So my question is, how do I make sense of this if I'm like right in between, if I'm in between intervals like this, it's going to get confusing, right? Well, not if we just keep track, right? We are at 2,200. If you go up 100 and over 1, where are we at now? What's 2,200 plus 100? It's 2,300. Right, so now you go up 100 again, you go over 1. You are now at 2,400. Then you can go up 100 again, and over 1, you're at 2,500. So, here's what you could do. What you could do if you want to plot points that are exactly on the corners of these little grid boxes is you can say, what's equivalent to 100 over 1? Well, I could have gone up 300 and then just write 3 units and not had to plot either of these points. Furthermore, if I want to just get to the next block, that's the same as going up 500 units to get from 2,500 to 3,000. And then right, we need to make it 100, 5, right? So each one of these rates of change are the same thing. So you could go up 500 over 1, 2, 3, 4, 5 home runs. And then just keep going that way. Up 500 over 1, 2, 3, 4, 5 home runs. Up 500. You see the pattern that holds with that. That was tricky. But I hope you can see how those points give us a more accurate version of that line. See how these are... Please ignore the bell. Bottom line is you've got this line for our linear model. And, sorry, that kind of messed me up a little bit. Yeah, that's it. So now, we've got the line. What's its equation? Well, it's y equals the starting point plus or minus the rate of change times x. So, y equals 2,200. We are increasing plus, if you want to put 100 over 1, that's fine, but when you're talking equations, you may as well just say it's 100, right? 100 over 1 is the same as 100, 100x. All right, guys. This is going to be a little bit different for you. You might have to make a lot of adjustments after this first assignment. You can be sure to see this kind of thing on the next assignment we do. So thanks for watching. Please email me whatever questions you may have, and if we need to Zoom to get some more feedback type, I talk, you ask questions, we can do that. All right, thanks.